All right, today we're going to dive into one of the most foundational attacks in the history of cybersecurity, smashing the stack. It's a technique attackers have used for decades to get total control of computer systems. And honestly, if you want to understand modern software security, you gotta understand this. So, how does it all work? Well, it all kicks off with a really simple question. Could a program, something designed for a basic task, like changing your password, actually be the key an attacker uses to take over the entire machine? The answer? Oh, it's a huge, resounding yes. And we're about to see exactly how. So, our story here is going to center on what looks like a totally harmless password utility. Now, this is a simplified take, but it's based on a real program that had a massive vulnerability found in Sun Solaris systems, which back in the day was a pretty big deal in the world of operating systems.
Look, on the surface, its job seems totally simple, right? It asks for your old password to make sure you are who you say you are, then asks for a new one twice, just to be sure you didn't have a typo. It seems solid, simple, safe, but hidden inside its code, a ticking time bomb.
Okay, so let's peel back the layers and actually look at the code itself, because deep down in this simple program, there is one single critical mistake, a fatal flaw that turns this helpful utility into a powerful weapon. Now, to get what's going on, you first need to understand a concept called a buffer. The easiest way to think about it is like a box. A programmer decides exactly how big that box is. Maybe it holds 10 items, or in our case, 256 characters. It's just a temporary little spot in the computer's memory meant to hold data for a short time, like the password you just typed in. And there it is, that line of code right there. Char password 256. That is our box. The programmer has set aside space for exactly 256 characters for the password. And that sounds like plenty, doesn't it? But here's the crucial part. That limit of 256 is absolute. The box can't just get bigger. And this is the exact moment where it all goes sideways. This function, scanf, is what takes the password you type and puts it into our 256-character box. But here's the killer flaw. Scanf is way too trusting. It never bothers to check how much you've typed. So if you feed it 500 characters, it's going to try to cram all 500 into a box that was only ever built for 256. This is where the attack gets its name. See, when you overfill that box, all that extra data, all those extra characters, they have to go somewhere. So they start spilling out, writing over other really important information in the computer's memory, in a region known as the stack. And this isn't just messy, it's catastrophic. So how does an attacker actually use this? Well, it's a four-step process. First, they create this really long, specially crafted string of data. Second, they feed it to the program, which causes that buffer to overflow, just like we said. Third, and this is the genius part, that overflow overwrites the program's return address. Think of the return address as a little signpost that tells the program where to go next. Finally, the attacker replaces that signpost with one pointing to their own malicious code. They've just hijacked the program. This whole technique really blew up back in 1996 when it was famously documented in a legendary article for a hacker magazine called Frack. The title was Smashing the Stack for Fun and Profit. This paper basically laid out the blueprint for the attack, and its impact is still felt in cybersecurity today. It took this bug from a theory to a powerful, practical exploit. So what's the end game here? It's not just about crashing the program. Oh no, the goal is way, way bigger. It's about gaining complete, total, ultimate control of the system. Let's look at the devastating payoff. And this right here says it all. Game over. That little hashmark symbol is the prompt for the root user on a Unix-like system. Getting that prompt is the computer equivalent of being handed the keys to the entire kingdom. It means the attacker is no longer just some regular user. They are now the system administrator. They own the machine. And what does having root actually mean? It means they can do, well, anything. They can read your private files, delete critical system data, install spyware or ransomware, execute any command they want. Because the password program itself ran with high permissions, the attacker inherits all of them. It's a total compromise. And listen, don't think for a second this is just some old-school theoretical stuff. Buffer overruns have been behind some of the biggest security stories in history. The Twilight hack used a buffer overflow in a game save file to break the copy protection on the Nintendo Wii. And the infamous Heartbleed bug, which hit millions of websites,
That was a type of buffer overread that let attackers steal sensitive info right out of a server's memory. Okay, so this sounds pretty bad, right? A devastating and widespread problem. So how do we fight back? The good news is the industry has learned a lot since 1996. Let's talk about how we detect and prevent this stuff. You know, the most fundamental defense is also the simplest. Just write better, safer code. Instead of using these overly trusting functions like scanf, modern programming demands that you use functions that always check the length of the input before you copy it into a buffer. It's a simple rule to live by. Never, ever trust user input. Always check it. Today, we use a whole multi-layered defense. Yeah, it starts with C for coding, but we add way more on top. We use automated tools that scan code for these kinds of vulnerabilities. Compilers themselves now add automatic protections, like something called a stack canary. Think of it like a secret tripwire. If an overflow hits it, the program knows it's under attack and can shut down safely. And on top of all that, modern operating systems have their own powerful defenses built right in. So, here's the real takeaway. While we've made huge progress, the basic idea is still so important. A tiny mistake, one line of code in a simple program, can lead to a complete and total security breakdown. Which really makes you wonder, doesn't it? If a flaw this massive could hide in a basic password utility, what kind of secrets might be hiding in the millions of lines of code that run the complex apps you use on your phone and your computer every single day?